Mm. Hmm. If you see the screen, you can see here that the uh, this is the ohm per oh sorry ohm per 1,000 feet is at NTP or 20 degrees Celsius. It is made standard. So this is the ohm for 16.2 ohm per 1,000 feet long wire. This is the resistance standard. Which wire? The wire which is having a diameter, okay, the diameter of the cross section, so this is the circular wire cross section. The diameter of the cross section is this, that value. According to that, you are going to find the area. So A equal to pi square r, like that. So the radius you can find, and then from there you can find it. And then you can see that the area will be what? That area, cross section area, will be this. So this is the cross section area of that thickness of the wire, and which is having this ohm per 1,000 feet. American people given, make it standard and given the number as 22. So that wire 22 American gauge wire gauge number means it is this thickness, which cross section area will be 0.324, and the per 1,000 feet of this wire will have a 16.2 ohm resistor. Now you can go to the market and you can buy how long wire you need for your primary side of the transformer, how long you need for secondary side of your transformer. That should come from your calculation. The resistance calculation gives you what should be the length, and according to that you can find it. And from the market you can go and buy it. And your design should be incorporated within this cross section area, within this cross section, because in the market these are the were available only. So you have to design your transformer according, based on this information, and then you can go to the market and buy it, and you can see. Now we are going to solve today our first problem based on this AWG, and we are going to use this table in order to solve the problem. It's okay.
Okay, sir.
Okay, good. Now I can clear the thing, because this is already nothing to go with us, and we are going to go forward to the next class. Yes, sir. Now this is what you all understood. Okay. I'm sorry. So to do what? Mm. Okay, I'm going to delete all these things. Yep, now go with that. Okay, and this got okay. Now this two can be done like that. Okay. All right. Now that's a question to the. That's the solution to your question. Answer to your question. Now, any other question regarding the last lecture, what we have discussed? Anybody got any question? No.
Sir, I
Yeah.
have a question regarding
Yeah.
the first quiz in the first lecture.
Okay, your speaker, your sound box, I'm sorry, microphone is a little bit disturbing. Okay, but anyway, we'll try to understand. Yeah, go ahead. Can you repeat? I'm sorry.
My question is, what is a linear circuit?
Okay, the linear circuit is uh, whatever the input, the linear circuit, then uh, it is the input and output is having a linear relationship. That means if you apply input to the circuit, you get some excitation. If you get some excitation, you get some response. Means you're giving some input, you're getting some output. Like you apply the voltage by the battery, you apply the voltage to the circuit, your response will be the current, let's say. So the what will be the current flow by applying a voltage. So the relationship between the input and output means the relationship between the voltage input, voltage and current in the circuit. So if the relationship is linear, that is a linear circuit, like y equal to mx is a linear equation. Do you know that? Okay, so y you assume the voltage, or y equal to mx, I can say y equal to mx is also linear. So like v equal to ir, as you understand, it is very much linear. It's a straight line. So it's a very much linear relationship. So this is a linear circuit. So this is what the linear circuit means. And the linear, non-linear
Sir,
relationship, yeah,
I think
non-linear
sir, the screen is
relationship.
frozen. We cannot see any change in screen. Maybe I cannot see any change in
Your
screen.
screen cannot be seen.
Yes, sir.
Oh, everybody having the same problem. You cannot see the screen, is it?
Sir, I can see the screen.
Yeah. So I think you're
Sir,
having
are
some
you
problem.
writing something like?
No, I didn't write it. I think those who can,
Yeah, okay, yeah.
yeah, everybody
Oh,
should
You
see
got
the screen. You can
oh.
check something wrong maybe in your computer. Is it?
No, sir. I think you are writing in the screen. So
No.
I
I'm
think
sorry. I'm
maybe.
sorry. I no, I didn't write. I'll not start the class up until 9:30. It is
Okay,
9:26.
sir.
I
Sorry, sir.
did not
It's
start.
a mistake.
Okay, it's all right. Okay, got it. I can put it like this. Okay, now let it be like this. No problem. Okay, now nonlinear circuit like RL, RC, that is involving the inductor, capacitor, those are nonlinear device. And I will discuss this thing after the midterm in my RL, RC circuit class. There you can see the nonlinear relationship or nonlinear circuit behavior. It should be fine. Thank you very much for your question. Any next question? Any other people got any other type question? Still, we are having 4 minutes to go. If no, then I'm just telling you, one of the guy send an email among yourselves that, sir, I have solved the practice problem, and then he sent me to check the answer, whether it's correct or not. And then I saw most of the problems procedures are good, okay, but the answer he got wrong because of some maybe mistakes there. That one he will check today in the class, and he will understand, I hope, that much better than rest of you, because he tried. Like him, if you tried, then also you should understand it better as well. Now, who is the guy actually sent me the email regarding this? Can you tell me who is the guy? Is he here?
Sir, I send you.
Oh, Muntasir Ahmed, Muntasir Ahad. Okay, yeah,
Yes,
like I can remember. Okay, Muntasir, in that case, you can cooperate me today when we are going to find the solution to the problems. I think it will helpful for everybody. Now, all of you, please,
sure, sir.
yeah, all of you, please be ready with your what you call that, with your uh, calculator, which is very important today. So everybody should take your calculator in front of you before we start the class, because you need to do a lot of calculation today. And don't show yourself smart that I know how to do calculation. It is very important to do a practice, because in the exam time you have to do it, remember. And that time you will be stuck if you don't have practice on it. Now, regarding the exam, actually I'm just announcing uh, on 6th week, sixth lecture, lecture 6, I'm planning to take the city one. So I'll announce it in the BUX. So just for your information, you can keep in your head that tentatively lecture 6, after finishing of lecture 5, then we will sit for our first class test, city one. So all of you practice on it, and you know that the question will be on solving the problems, not explain what is resistance, what is capacitance, those sort of things. So all of you be careful about it, learn the how to solve the problems, understand how to solve it. Like these sort of things are very important for you to know in order to uh, answer to the question in class test city one. Okay, so I hope that we are coming close to 9:30. If you do not have any question, if you have any still, then after the class, please knock me, sir. I have some question. We can carry on. And those who have another class, you can drop the class and can jump to the next class. This is how we can go. But I have another class today after this as well, so we can see how it go. No problem. Okay, so it's 9:30. We can go ahead with our normal class as we are going to start today. Okay, sorry, this is the practice. Okay, now this one actually the first problem, as I have given to you and told you to solve today. Now if you go with this problem, then I think first thing you can see where is if you read the question, I'm hoping that most of you have gone through the question already, but still if somebody did not. A wire is run across a 2000 feet span to a high power lamp that draws 100 ampere, and if a 4 AWG gauge, if a 4 AWG gauge wire is used, how much power, that what you have to find, how much power dissipated or wasted or lost in the wire. So this is the question. That means you can imagine this is the substation in your big house, and this is the floodlight. The floodlight is required to play football or some sort of in the ground. So you have a connections like that, and this is the wire from the substation to the from substation up to the load. This is 2000 feet distance. The current flow from the substation, from the transformer to the flood lamp bar. So that a lot of lamps are there, as 100 ampere altogether this drawing. So the current is flowing through this wire is I, for example, and the value of the current is flowing through this is given there as 100 ampere. So 100 ampere current is flowing from the source to the sink, that is from here to here. And you know, at home, if you see, there are two wires required to close the circuit. One wire is the wire which is this wire, which is the red wire. This is actually in your home, you can see the wire is a red wire, and another wire from the load back to the thing to complete the circuit is a black wire. So this is the red and black wire. You can see the current is flowing from this to the red wire. Through the red wire, it goes from the source to the load, and the black wire, it is coming back from the load to the source and complete the full circuit. That means 100 ampere current is flowing through this red as well as black, and these two red and black are combined together. And in your house wiring, in the wiring system, if you look at, you can see these two wire are going together. So the red is the life and black is the neutral. You can think like that. I think everybody know that. So this is the way actually the current is flowing 2000 feet. It goes from the power source to the load, and from source to the power source, from source to the from load to the source, it is coming another 2000 feet and coming back to the source. So this is the way the current is flowing. Now what happened in the copper, in the line, the 2000 feet long conductor is having resistance, and this resistance we can say that it is R, is the resistance through in this conductor. Hey, this resistance is a lumped resistance or it is a distributed resistance? What type of resistance is this? Can you tell me? Yes.
Distributed resistance.
Absolutely. I told in the last class as well, distributed resistance. because it's distributed through the conductor, distributed throughout. So 2000 feet long is the wire, and it distributed, the register is distributed. Lamp register, I think I told you, is a color code in the lab. You can see. Are you okay? I think that's all you can. I discussed in the last class. So this is distributed register, and that register is consuming the power, and that power you have to find in this point. I mean, in this question. So if you want to find the power that is absorbed by the resistor, so you are going to go for power. You have to find absorbed by the resistor, ER. What will be the equation of the power? Last class I told about the power equation. There are three equations. If
I square R for this
absolutely
case.
good, that is what I want to know. That the three equation, out of the three equation, the equation which is I square R, that is what we are going to use here. So this is what you have to find. So our question is P equal to what? Our question is P equal to what? And solution is, it is the way we are going to find the solution. That is P equal to I square R will be the equation we are going to use. Now, if you go for this I square, what is the I square? I equal to what? You know that I equal to 100 ampere.
Amperes.
Yes, sir. Then what is the R? That is the big question here. Now, if you want to find the value of R, then you have to go through the resistor value, and the resistor, what is the conductor? Is it only the information given here? The conductor size is 2000. Yeah, 2000 feet and 4 AWG. So 4 AWG means you have to go to the table. Okay, for the table just now today also I've shown you the American wire gauge table. So from the table we have to look for 4 AWG gauge. So what is the 4 AWG? What is the 4 AWG register? That one, I'm sorry.
0.2485.
Okay, you can. I think you have it already, right, with you. So you can just go for it. Yep. Then you can find it. What is the thing? Okay, now let's come back to the point. I think some of your friend may be confused. Yes, I'm going to bring it, and we can go ahead with that later on. Okay, now look at it. Just for your information, then it will be easier for everybody to go. Now look at it. 4 AWG gauge is here. This is the one, 4 AWG up to this. So 4 AWG, if you consider the resistance is this value, okay, what is that value? Resistor is ohm per, what is that? Ohm per how many feet? It is ohm per what? 1000 feet. Is look at it, ohm per 1000 feet. So this is ohm per 1000 feet. Remember, this is the information we have, that it is 0.2485, 0.2485, as your friend said, it is 0.2485 ohm per 1000 feet. Per 1000 feet. This is the resistance we got from there. But in our case, the resistance will be what then? What do you think about this got? Will be resistance will be what here? Is
4
it
times?
Yeah, 0.2485
times 4.
Yeah, because per 1000. It is the mistake I think your friend had made in his calculation. You remember? Okay, you consider 2000 feet is the length of the wire, but actual, just now one of your friends said times 4. Why times 4?
It's time 2.
Because there's 4,000 feet of
4,000 feet the wire current travel 2000 here and another 2000 here. So altogether it will be 4000 is the total length of the conductor wire, or the conductor of the wire. So 2000 plus 2000, 4000. It is for 1000, but you have to go for 4000, that you have to multiply by 4. And your friend multiplied it by 2. And I think most of you had done the same mistake. Most of you considered 2000 feet and multiply by 2. Yes or no? Tell me first. Hey, tell me the truth. Isn't it? Most of you have
Yes, sir.
made it 2, right?
Yes, sir.
Yes, sir. Good. Excellent for confessing the truth. Right. Good. You see the email always on the bottom of my email is always written, you have to speak the truth. Remember, because I'll give you at the end of the class for a 2 to 3 minutes a short lecture on the HQD, human quality development. So this is very much important. So some attributes we need to have. That one I'll talk at the end of the class today. So maybe we can, any day we can do it. So now let's come back to the point. If you multiply 0.24, anybody can tell me voluntarily from your calculator, what will be the value? If you multiply this, then what will be the value coming?
0.994.
0.994. Good. So this is the resistance you are getting. So you write here 0.994. If you write it, then what is the value coming if you multiply? Anybody tell me now?
So 9940
Watts.
Okay, 9940 watt. Okay. If I say a kilowatt, what will be the kilowatt?
Yes, sir.
9.9.
9.4 kilowatt. You divide by 1000, it is in kilowatt you are getting. So this is the answer to this question. That is how much power is lost through the transmission line or through the wire, through the conductor. This is the amount of power loss through the wire or through the conductor. I think everybody understood the answer to the question. Yes.
Yes, sir.
Okay, good. Now, what you call his name? Musfik, Muntasim. Is it Muntasim? I'm sorry.
Yes, sir.
What's the name of the guy who? Yeah, Muntasir. Okay, Muntasir.
Yeah.
You understand it now?
Yes, sir.
Good.
I understand it now.
Okay, great. Now I'm
Okay.
telling you all. You just we are going to do some additional thing in this problem. You please note it down. The additional thing I'm going to show you here is the, I'm going to wipe out this thing first, then I'm going to tell you what are the additional thing. Okay, I think this is the direct answer to the question. Everybody understood, so I'm going to wipe out this thing and I'm going to add some additional thing on top of it and then see how we can do it. Okay, now let's come back to the point. Additional thing is I'm going to tell that also you calculate, find, okay, find the power, find the system loss, system loss equal to what if the voltage, load voltage equal to
Sir, I
220.
cannot see the screen, sir.
Just a minute. Okay, 1 second. Yeah, now it's all right. 1 second. Reverse better. Oh, okay. 1 minute, send. Okay. 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 Now, can you see the screen now?
Yes, sir.
Yes, sir.
Okay. Now, we have only 10 minutes to cut the line as a Zoom process, you know. So everybody come back after the cutting. Okay. Now let's come back to the point. It's an 8 minute 20 seconds left. Now, you have to find what is system loss here, and if the voltage is plus minus plus 20 voltage, 220 volt means this is the load. The voltage across the load will be 20 here equal to 220 volt. 220 volt. I'm talking about the voltage across the light is 220 volt. Current is going through this is 100 ampere, as you all know that it is 100 ampere current is flowing, and voltage is 220 volt. If it is something like that, what is system loss? Now, before you go for a system loss, you need to know what is the definition of system loss. Now, okay, I think this this thing we don't need. Okay, this thing we don't need it, so I'm going to discard all here all. Okay, now it says there. Okay, fine. Now, if you go with the system loss definition, system loss is a very important thing. In PDB, RDB, if you go and tell the engineers, hey, what is system loss? Some of them don't know maybe what is system loss, but system loss is a very important, but they will tell you, if you ask them what is the power loss in Bangladesh, what is the system loss in Bangladesh? That means how much power is lost in the transmission line. If you go in the village area or some area, they can see a long transmission line, because from Ghorashal to Dhaka, the power comes through the transmission line. There is a big loss in the transmission line, and on the road also you can see a lot of wires, and it is having a lot of power loss. This loss is known as system loss actually, because this power loss in the wire or in the conductor are not in use, it's unused. So this is what called the system loss, is very important thing. So in Bangladesh, it can engineer will tell you, oh, our system loss is 30%, 40%, 20%, like that. What does it mean? That is the question. So I'm just going to write here the system loss definition will be, system loss is nothing but equal to the PL. I'm just writing here PL, the power loss in the line, divided by PL, I think P loss, P L, line loss, P line, or where, or PR, just a PR will be better. Okay, I'm writing PR. PR means the line loss, PR divided by P loss. I think better P loss, then everybody can understand it better. P loss, and this is P loss, okay, and plus P load. P load. Load means the how much power we are getting at home, will multiply by 100. That is in percentage, is the power loss. P loss divided by P loss plus P load. That means how much power is lost based on the power supplied. That means the total power supplied, the P total supply. That means your P loss, ultimately you are getting what? P loss by P total supply. Total supply means P supply, you can say. P supply. Supply, the power supply, and that is 100, multiply this. This is the definition of system loss. If you say that is the system loss, means how much loss in the line, how much power they are sending, that is the question. Now if I say Ghorashal is sending, just for your information, I'm just telling you, if Ghorashal is sending, okay, I'm going to show you here. Let's say this is Ghorashal. Ghorashal is sending 100 megawatt, and at home in Dhaka city, or we are getting the power from there only 80 megawatt, for example. Can you tell me how many power is lost on the line?
20%.
20 loss. So 20, if it is 20, then the system loss calculation is very much either this or that, whatever way. The 20 divided by 20 plus the loss load side is we are getting 80 watt into 100. So that means we are getting the system loss is here 20% system loss. And if you use this equation, it is straightforward. You got the value because the loss is 20 and the total supply is 100. into 100. So ultimately you are getting 20%. Whatever is the same thing, same equation, same value. So either this, that, same thing. So ultimately what we can say that the system loss in this case will be 20%. So your case, likewise, in our problem, according to our problem, what will be the system loss we are now going to calculate? I think everybody understand it, how to do. So I'm just keeping this slide as it is so that you can get it. Now, system loss will be, in our case, system loss will be what? Now, in order to find system loss in our case, you have to first system loss on the line, P loss on the wire divided by P loss on the load, P loss and plus P load. That is what we have to find, and then multiply by 100. Now, first question is, what is our line loss? We already calculated. Hey, what is the loss in the wire? Just now we calculated. What is that? Dux.
9.94
kilowatt.
9.994.
9.94 kilo.
9.94. Okay, 9.94 kilowatt. Is it correct?
Yes, sir.
Okay, good.
Yes, sir.
Now, again, P loss here also it will be 9.94, but plus only the thing we need to find P load, and if we can find P load, then we can find the system loss. Let's go to P load calculation. That is our main thing. So P load will be what here? It is, forget about this thing because this is for mega. That's a different, but we are going for our calculation. Our calculation here is a P load means in the load terminal, what is the power loss here? Over here, the lamp, the light is consuming power, that is a load power. So what will be the power here? What equation we should use in order to calculate the power loss? Tell me. Which equation? P equation.
To IE.
P equals to IE. Everybody try to understand what he said. So P equals to I, he said it is I into E. I into E. And what is the value then? I equal to what? Hey, what
100.
100 ampere. And the current flow through the load is 100 ampere. 100 ampere, right? It is the 100 ampere flowing through the load. So 100 ampere times, what is the voltage across the load?
20.
220.
220. And if 100 and 220 multiply, what is the calculator say? Can you see now?
Yes, sir.
Okay, good. I think all of you are
Sir,
now.
I have a question here.
Yes, sir, go ahead.
Sir, why are we using voltage here to measure the power loss?
No, not power loss. This voltage is required to calculate the power the light is consuming. This power is the load power. And earlier 9.94 the power is the that is power loss in the wire. And this is the power we are using in the light. So wire power and light power is adding together, giving you the total power supplied by the power supply. So voltage is required here to calculate how much power the light is consuming. You understand?
So this voltage is light's voltage actually.
Right. The voltage across the light.
Voltage across the light is.
Yeah. And the current flow through the light is 100 ampere. The voltage across the light is 220 volt. So what is the power? Hey, last class headlight power you calculated, right? What is the voltage across the light? 12 volt. What is the current flow through that? And then your power you can come in. Can you remember the headlight power?
Yes, sir.
How you calculated the voltage and current multiplication, right?
Yes, sir.
That's like that. Instead of headlight is a floodlight. I think it should. Okay. Now what is that? 22 kilowatt. Good. Thank you for asking this question. You are clearing everybody. Everybody now clear, I am pretty sure. Okay, now this is 22 kilowatt. The light is consuming. I'm giving this problem to get a clear conception for this thing. That's the reason. So everybody can have a clear idea. Okay, 22 kilowatt multiplied by 100. Now, what is the calculation? Hey, dumps, all of sleeping. What is the answer? Now you, Muntasir. I think everybody, it's new to everybody. You just do the calculation and tell me what is the answer.
31.12.
31.12.
Good, 31.12%. Everybody, please keep it your calculator ready. Okay, this is the system law. Yeah, this is the system loss. This is the system loss in this case. So now you understand how to find it. Now listen, one of your friend asked me question why I use the voltage and ting tang, and I told you this is in order to calculate the power loss consumption. Now anybody can tell me how much power PDB or the power supply have supplied the power. How much power is supplied from the substation to your floodlight so that you can play football game or badminton game or whatever. What is the power, the substation, the power source means this is the substation, right? Substation at your big place. So how much power the substation should deliver to your system altogether? How much?
Sir,
Can you tell me?
41.06.
How you
kilowatt.
found it? Can you please tell me?
Sir, by summing loss and load.
9.94 plus 22. What is the answer?
31.94.
31.94 kilowatt. This is what the power supply by the substation. Substation supplied that power and you are getting 22 kilowatt, and rest of the power is lost by the wire, the copper loss. This is absolutely loss, nothing to do in the wire. You have to. That's why we want to reduce this loss. People want to minimize a lot of research is going on to minimize the loss to 0 watt. If it can be 0 watt, system loss will be 0 watt. It's not possible, but if can be, then if you produce 100 megawatt power, all 100 megawatt will come to your home. No loss will be on the transmission line. Then it is a 0% system loss. There is no loss. But it is not possible to make it 0 watt because the wire must have some loss, which is a superconductor. A superconductor may be a 0 watt, but this is not existing. Research is going on that. So that is all about your system loss things. Maybe in your future life, you can find the superconductor, which is 0 ohm resistor. If the resistance value are equal to 0 ohm instead of some, then you can get loss is 0. But how come you make 0 ohm resistor in the conductor? There is no conductor which is having 0 ohm resistor. If you can find it, then you get a Nobel Prize because you are going to save a lots of power. All right, that's all about the problem. Anybody got any question? Please let me know if you have any question regarding this. Okay, if no, then we are jumping to the second problem. The second problem is here like this. I think again, most of you have tried to solve this problem, and we will see now how to do it. Okay, Muntasir. Sorry, I think none of you can see this thing.
Yes, sir.
Yeah, just a minute. I'm going to show you in a bigger form, a little bit down, so that everybody can see now. Now I think everybody can see. Yeah, can you see the problem? Second one.
Yes, sir.
Yeah, Muntasir, I think you can check your answer now. Is correct or not? And this. Now, if you read the question, what is the question said here? Is the question is let be the current, let I be the current through and V be the voltage across a resistor R, which is 1200 ohm. Then you find the power being absorbed by the resistor. Resistor is always absorbing power. So here things are given like that. If you go with this thing, then you can see this is given here. What is given here is okay, is given here a register is here, okay, and the register's value is given here as 1200 ohm, and a current is flowing through the register. We can assume it is I, and the voltage across the register is considered as a V. So current is flowing here to here, V. So if this is the scenario, then you have to find what? That's a question. Find number one, you have to find, what you have to find is a power. All what you have to go for is to find the power at what? At power at 0.1 second. 0.1 second. At this time, what is the power? You have to find it. 0.1 second. Because it is a time varying case. With time, it is changing. So when time is 0.5, then what is the power? That's what you have to find for each cases. For each cases means for number 1A, if the current is given here like this, if the current is given this milliampere, this is for A. And B case is if the voltage is given like this, and C case if the V into I is given like this. These are the three cases you have to find the power. Now, if you go for solution, then first solution we are going to find, first solution is for A. If we go for A first, then what will be the power for A? If you go, then P will be equal to,
0.0435 watt.
yeah, what is the equation? Because I is given,
I square
R is given. Yes, this is first thing. For A, the given is I. I is given here, remember, I is given. So your resistance is already given. Now I is given. So I is given and resistance is given. These two things are given in A. So the equation for power will be I and R. I and R means you already know that it is I square R. Good. One of your friends already told that this is I square R. Now if it is I square R, now you tell me what is I? I is here given 20 into e to the power minus 12t. 12t, and t is what? T is 0.1 second. 0.1 second. That is the power you have to find for. So this is the thing, I square R. But one thing you remember, what is this guy? This guy is in
Milliamperes.
milliampere. So milliampere, you need to better change the unit first. And a unit will be what? Is a milliampere, you have to convert it into ampere. So how to convert milliampere into ampere? This is important. Can you tell me? Minus 12 into 0.1. What is the way? 0.1. This is milliampere current.
Times 10 to the power minus 3. 10 to the power minus 3.
Minus 3 is the ampere. This is the total ampere you are getting. So it is I square. So if it is I square, that means you have to write a square here. That is your I square in ampere. And R is your 1200. So you write here 1200. Fully stop. It is done. Now you can do your calculation here. Now, can you all do this calculation and tell me what is the answer?
0.0435 watt.
All of you got the same answer? Check.
Yes, sir.
What is that? 0.043.
0.043.
0.043. After that, what is the next digit?
5.
P is given and R is given. So if you want to find the P, what equation of P?
Sir, I cannot see the screen, sir.
Sir, I
Just a minute.
cannot see the screen also, sir.
There is a
I'm sorry, just a minute.
The black screen appeared.
Okay, okay, now can see.
Yes,
Yes,
sir.
yes, sir.
Yes, sir.
Okay, that's okay.
Yes,
Now let's
sir.
come back to the point. Yeah. Now let's come back to the point.
No,
What
sir.
is the equation for this case B?
Sir, I can't see.
You can't. I think something wrong there then.
No, sir.
I think everybody should see now.
Yes, you can see now.
Check your connections or
Yes,
something.
sir. Yes, sir.
Okay.
It's
What
okay,
is the equation? Can you tell me? In B case.
Sir,
You can. It's a V given in the case.
B is square divided by R.
IE.
Yes, because in this case, second case, V and R. V is given and R is given, but I is not given. In the second case, I is not given. Only V, because V is given, R is always given. So it is V and R. So the formula will be, as you say, E square by R. That means V square by R. Good. Now, if you go for V square by R, then you can easily write it like this. 40 into cos of 20 into T. 20 into T for 0.1, T is 0.1 and R is 1200. Okay. And you have to, this guy on the top will be whole square, right? 40 whole square. So this is how you can write it. Now you can do your calculation for this. What is the answer coming? Now, Muntasir, what is
1.33.
what is the value?
1.33, sir.
I'm sorry, come again.
33.
331.
Okay, all of you got 1.33. 1.33. Anyone else got different answer? No. Hey, ducks. Everybody got the same answer.
Yes, sir. Same answer.
Okay. All
sir.
goes in the wrong
Yes,
way.
sir.
That is the right way. You all are wrong. The reason is, what is the mode of your calculator? Is in degree, radian, or grade?
The degree.
Degree. Everybody's calculator is in degree mode, and that is the mistake here. The reason is, if you see the equation V equal to 40 cos 20t, which is like, I'm just writing here, V equal to 40 cos, you can remember omega t, the equation. So omega t, omega is in radian per second.
Radian,
It's a
yes.
radian. Yeah, this is your 20t means the radian per second, not in degree mode. So you are writing here this 20 radian per second, omega. So your calculator should be in radian mode. So can you please change your calculator into radian mode and then redo the calculation? I think you should know how to change the radian mode. And tell me what is the answer. And Muntasir, your
It's
answer is
0.23 watt.
okay, 0.231. This is the wattage, means if you convert into milliwatt, it is 231 milliwatt multiplied by 1000. So these are the answers you are getting from this problem for number B. Now you go for number C. If you go for C, then what will be the thing coming there? I'm going to do it here, number C, so that everybody can get it in one shot. Okay, C is coming here like this, like a P is nothing but, in this case is given already, V into I. Hey, power equation is what? V into I. So it is already
V
given
into,
V into I,
EI.
right? So you don't need to do anything here. It is given already. All you have to do is do the calculation, nothing else. That 8 into T is 0. What is the value of T? 0.1 to the power, yeah, to the power 1.5. Volt ampere means is a watt. VA, volt ampere means watt. So you can write straight away this. What is the value now? 8 into 0.1 is
0.25.
0.25 watt.
0.25
0.25 watt. 25
watt.
watt.
If you multiply 1000, what is that? 250 milliwatt, isn't it?
3 milliwatt.
Yeah. So these are the three answers to this problem. I hope that Muntasir, you can correct it now. Only your problem was here,
Okay,
most
sir.
probably, right? B, because of radian mode. Yes, Muntasir.
Yes, sir.
Yes, sir.
Yes,
So
sir.
yes, that's it. Other than that, what you have done is absolutely correct. So this is the only thing you have to take care. That's fine. Now let's jump to the next problem. Next problem is this one. All of you can follow me, I hope that okay. Now if you go with this, the next problem, then we can see here, all of you can see the screen.
Yes, sir.
Okay, good.
Yes, sir.
Look at it.
Yes,
The
sir.
total charge accumulated by a certain device is given as a function of time by q equal to 18t square minus 2t to the power 4. It is an SI unit. Don't need to worry about MKS unit, FPS unit. You know that. It's in a meter time, like sort of things. So this is the function of charge given. What does it mean? You should understand first the charge accumulation in a certain device. Hey, what sort of device can accumulate charge? Accumulation, you understand, means what do you call that? Accumulation means you know, storing the charge. What device store the charge? Can you tell me?
Capacitor.
Capacitor. And what is inside your pocket? You talk to your girlfriend all the time. What is that?
Mobile phone, sir.
What is that? Inside the
Mobile phone.
mobile phone. Inside mobile phone, charge is accumulating somewhere. What is the name of that duct?
Battery.
Battery. Absolutely. When battery finish, you connect it to the charger and charge is accumulating there. So battery can be a device. Capacitor can be a device. So like sort of a charge storing device. Anything can be, along with the circuitry. Circuitry, you know that if you see the thing inside, the charging, fast charging circuit, all those sort of circuitries there. So the battery or the capacitor circuit is charging the capacitor or the battery through with time it is charging. So the relationship between this charge accumulation, that is charge is storing with time, is given by an equation, and that equation is this, which is very much non-linear. No doubt it is not a linear. Hey, this is a non-linear circuit. This capacitor itself is a non-linear element. I'm just talking about this charge and time relationship is very much non-linear, because this equation is a very much non-linear equation, you can say. So with time it is changing. Means if you go for, hey, look at it, if you go for times q and this is t, q is the function of time, right? Hey, you understand it?
Yes, sir.
Okay, so at
Yes,
time
sir.
t equal to
Yes, sir.
0, yeah, then you can see that it is going to be like sort of, I'm talking about, it's a non-linear relationship. It's not a straight line. You cannot say it's a straight line or it is straight line. Is it a straight line equation? Y equal to mx plus c?
No, sir.
No,
Of
sir.
course
No,
not. So you
No, sir.
understand it, yeah. So this is a non-linear relationship between the q and t. It is given here in the question, the relationship, because this is the way the capacitor or the battery is charging. So with time it is changing the charge. So question is, if this is the scenario, just I'm drawing it again, if this is the scenario, the time t and q, and it's like that, so 0 second, 1 second, 2 second, 3 second, like that. So the question is, first question is, what is the total charge accumulated? How much charge is accumulated at time t equal 2 second? At time 2 second means this is 2, ting, 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 you come here. This is the charge accumulated at 2 seconds. This is the amount of charge in your mobile or in the capacitor. This is the amount of charge already accumulated after 2 seconds. This is the question A asked you. The question is how to find it. Straight away we can find these things straight away by calculating the time. Okay, but I'm just telling one thing, you should remember, understand it, that this is what q, it's like that, and this equation is actually q equal to 18t square minus 2t to the power 4. Actually this is the equation of this line. So 1 2, so 2 is coming here, so this is the thing you are going to count the 2. What is the amount of charge? You have to find it from this equation. That is what I'm talking. So straight away 2, you put it into the if you put the value of 2 into this equation t, then you can get the value, what is the amount of charge accumulated at the time. So straight away we can do it over here in from the equation, and I think most of you have done it already, most probably. Now look at it.
Coulomb.
Yeah, solution we are going to do. Oh, you've done it already. Good. I think this part you can find like this. Q for 2 seconds. You have to straight away write the equation 8 into 2 square plus minus 2 into t to the power 2 to the power 4. Yes, what is the answer you said?
40 Coulomb.
40 coulomb.
46.
40 coulomb, the charge. Okay, coulomb, 40 coulomb is the answer. That means after t second, 2 second, the capacitor or the battery store 40 coulomb charge. That's the way. Now, second question, let's go to the second question, number B, which is, what is the maximum charge accumulated? What is the maximum charge accumulated within 0 to 3 milliseconds, 3 seconds? That means the charge accumulation, as charge how much accumulated is a maximum we have to find. Now, if you want to find the maximum charge accumulation, then maybe I can show you here. Okay, we can see there, no problem. If the thing is coming like this, as I show you the graph, the relationship of the Q and T, and T and Q, as you saw, like it's coming like that. So for example, at maximum, what is the charge accumulated? This is the maximum. You can see the charge accumulated maximum over here. Another, you are familiar with the maximum minima, here maximum here, another maximum here, like that, and maximum here, like sort of things. So
Yes, sir.
in order to find the maximum minima in mathematics, you have gone for a method or equation. What is that?
Differentiation.
Differentiation. So you know that the slope at the point is equal to 0. So the slope at this point, this is the maximum minima points. So from this condition, you can find at what point it is giving the maximum value. So dq by dt equal to 0 gives you that information. The maximum charge point can be found from there. So you can easily find it from here, that dq by dt equal to 0 means dq means 18t minus 2t to the power 4 by dt equal to 0. This can gives you the information here. So if you do it, what you get? It is 18 minus, what is that? 8t cube equal to 0. So from here, you can find what the value of
18t square হবে না?
T square, right? It is t square, right? You are right. 18.
Sir,
Just a minute.
I think it will be 36.
Yeah, 18t square, right?
36t.
Yeah, 36.
36
You're right,
minus.
you're right. Yeah, right, sir. I'm just sorry. Yep. What is that? 36t, right? 36t minus 8t cube. It's okay.
Yes, sir.
Sir.
The t you can take out. 36 minus 8t square equal to 0. You can say. So you can say t cannot be 0, because at time t equal to 0, it cannot be maximum charge, cannot be, because you just on the switch to charge your mobile. At the beginning, mobile cannot be maximum charge, common sense. So at time t equal to 0 cannot. So the other things will be equal to 0. That is 36 minus what? 36 minus t. So can you tell me what is the value of t there? Then 36 minus
So 3 root 2 divided by
80. 80 cube. Oh my god, I have made a mistake here. It is t is taken off, t square. Yeah, equal to 0. And t is coming here. If you do the calculation, it is coming here. What is the direct value?
3 root 2.
I'm sorry, can you do it again? 2 point?
Sir.
Yeah, 2 point what?
So 2.12.
Okay, good. 2.12 second you are getting. Okay, I think everybody got it. That is t equal to 2.12 second. That means this value is 2.12 second. At t equal to 2.12 second, you get the maximum charging point. And question is, what is the maximum charging point? And also second question, and when it works, when it occurs, it occurs at 2.12 second. And what is the maximum charge? The Q max, it is Q max.
40.5.
Yeah, that Q max you have to find, right? Good. So that at that time the Q max will be, okay.
Q
Okay,
max is 40.5.
how you can find it? Let's go to the next page. Q max equal to, you have to substitute the value into the equation, which is 18, what is that, t square. 18 t square means 2.12 whole square minus, what is that thing, is, what is the equation? Minus 40 is 40 cube, is it?
2t to the power 4.
Or I'm sorry, 18 t square, 2 t to the power 4. This is 2.12 to the power 4. This is the equation. Now you have to do the calculation. What is the value? Now you tell me, what is the answer?
40.5 coulomb.
40.5 coulomb. This is what the maximum charge, Q max, you are getting. So what does it mean? It means this value, you look at it, this value is 40.5 coulomb. This is 40.5 coulomb maximum charge you are getting at 2.12. Question is, does it make sense? Yes. Why it makes sense? Because, hey look, because at 2 seconds you are getting 40 coulomb, right?
Yes, sir.
Yes, sir.
Okay. 2 seconds is here, something here. So 2 seconds you get 40 coulomb. So 40 coulomb. And 2.12 second, you must get more than 40 coulomb because it is the maximum charge. So maximum value must be more than 40. That means we got 40.5. So it makes sense. If your answer, if your calculation gives you 39 coulomb, will it be correct or not?
No, sir.
Correct.
No, sir.
No, sir.
Because
No, sir.
30 is less than 40. It cannot be less than 40. It must be more than 40. Because at 2 seconds, we already got 40 coulomb. That maximum value must be more than 40. That's what everybody understood. That actually it makes sense that it is 40 coulomb per second. Okay, fine, no problem. We are getting this. Okay, okay. All right. Now 40 coulomb we got here. Now let's come back to the next part. Okay. Now,
Sir, I have a question.
yes, sir, please go ahead.
What if the question was minimum charge accumulated in the interval like maybe 1 from 3 seconds?
Minimum charge where you got?
I mean, what if the question was like that?
If the question is like that,
Yes,
I'm
sir.
sorry, I couldn't understand your question. You are asking me another question. What is the minimum charge accumulation?
Yes, sir. Like, what if the question wanted me to find out what is the minimum charge accumulated in the interval, maybe from 1 to 3 seconds?
No, that one actually you cannot find it because you have only one time you got. Is it make sense?
Sir, not really.
Okay, because you get the slope at equal to 0 at only one point, which is t equal to 2.12. Right? That means at
Okay, yes, sir.
point you are getting on or maximum. That means there is no minimum point like that. That means the curve is not actually like this. It is assumption. Actually, in our original curve from this equation, it should not have a minimum point like that. Otherwise, the time t should comes more than one value.
Oh, okay, sir. Okay.
Okay, now let's come back to the next point. Question number C, if you go, then at what rate is charge being accumulated at t equal to 0.8 second. Rate of charge is the thing now we have to find. Rate of charge means rate of charge, this is C. The rate of charge means what? dq by dt. This is called rate of charge. The rate of charge you have to find for t equal to what? 0.8 second. And the rate of charge means you can easily understand dq by dt is q is 18t square minus 2t to the power 4, and that gives you the value of the rate of charge. And by definition, rate of charge is, hey, remember last class we have told you q by t. Hey, what is that q by t? Dumb.
Current.
I, good.
I.
This is
I, sir.
static case. If it is a time varying case, then it is it, and then it is qt, all small letter, remember. dt, and that this is t dt. dqt by dt is the small, this is the rate of change. That means your change of q1 minus q2, q1 minus q2 by t1 minus t2, like that. So that means a delta q by delta t, like sort of things. So this in time varying case, it is small letters are time varying case. With time it is changing. Q is a small q, remember. This is the way actually the time varying and static are designed. So last class we saw in the static case. Time varying case we are going to represent with function of time. So dq by dt was giving you actually the current, which is it, and that's why we should write here, this is nothing but it at time t equal to 0, t equal to 0.8 seconds. What is that? As we are getting this value from here. I think you already done it. What is that? 36 t minus
80.
Minus 80 square.
80 cube, right?
80 cube, yes, sir.
And then you substitute the value of 0.8. What is that coming? 0.8
24.704.
0.8 cube. Okay, now you do the calculation. Yeah, what is that? 24?
0.704.
Okay, 0.7 is enough. What is the unit? Which is very important. Tell me. What is the unit?
Ampere.
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 Ampere. But it is q by c, q by t. Q by t is what? Coulomb per
second.
Coulomb per second. Last class we saw coulomb per second is nothing but ampere also. So 24.7 coulomb per second or ampere, whatever you write. Okay. Okay. Or ampere. So it is the current, or you can say this is rate of change dq by dt, rate of change of currents at time t equal to 0 is giving you this answer. So the answer is 24.7 coulomb per second, or so at 0.8 the current is that value. Okay, now I think you all understand it, the number C. Now we have to go to number D. This is number D, actually you all understand it. This is D. So in the D case, what to do? I think everybody understood so far, right? See?
Yes, sir.
Okay,
Yes,
now
sir.
we are going to go for D. Sketch the graph or curve Q versus T and I versus T. Q versus T, you can sketch the graph from this equation, very straightforward, because Q versus T is coming from here. Straightforward. I think everybody understand. With time, how it is changing, this can be found from here. But I versus T, when you go for I versus T, then I is what? I is, as we
Q divided by T.
dq by, right, dq by dt. And dq by dt, you can convert into I, and then I versus T. These two graph you have to develop now. Now let's go. In order to develop the graph, we have to calculate, we have to do some calculation. And for that, what is that calculation? For calculation, this is a Q and this is I. The table, you have to calculate the table. So if you want to calculate the table, then in the table you can write Q is equal to what? 18t square minus t, what is that? 2t to the power 4, right? 2t to the power 4, the
Yes.
equation for Q. And if you go for I equation, so I equation, you take the derivative dq by dt.
Yes, sir.
What is the equation we got?
36t minus 8t cube.
Okay, we can see what he said, that dq by dt is 36t minus 8t cube. This is the current. Actually, you all understand. This is nothing but the I. This is the I, as I have shown you here. This is IT. So if this is I, what's wrong here? Okay, if this is I, then you can write, I'm sorry, what is that? 36.
36t minus
36.
I cannot
Sir,
see the
there will be
screen,
a
sir.
timeout in 1 minute.
Oh yeah, we are running
Minus
out of
8
time.
cube.
We are running out of time, right? 1 minute. I think we have less than 1 minute. So we have to come back again. I better can restart. Minus 8t cube. Okay, let it be like this. We are going to out from the Zoom now, and we have to come back. And after that, we are going to start. But this is the thing now. We have to go for t equal to 0, t equal to 1, t equal to 2, t equal to 3. What is the interval in the question set? 0 to what? The interval.
0 to 3.
Greater
0
than
to
equal to 0, less than
0
equal
to
to
3.
3.
0 to 3. You can see 0. Okay. So can you hear me now?
Yes, sir.
Okay. Now look at it. This is what we saw, that 0 to 3 is the interval. So within 0 to 3, we have to do this calculation. So let's go to the slide for this calculation. Now 0, 1, 2, 3 seconds we are considering. But if you want to do a better graph, you can consider another interval like 0.5 in between, then 1.5 you can consider. So it will be 1.5, 2, and then 2.5, 3. That will be giving you much clear graph for these things. Now all of you, please start doing the calculation. I think some of you have already done the calculation. I think Muntasir, can you tell me the answer, and rest of you can check your answer is correct or not. Muntasir, are you here? Yeah, for
Yes, sir.
for 0, what is the Q value?
0.
Rest of you can check the answer. Yeah, go ahead, Muntasir.
For t equal to 0.5.
No, for T
No,
equal to 0, Q equal to what?
q equal to 0, sir.
Right, that is 0. Then T equal to 0.5, what is that?
It's 4.3.
4.3. Everybody check correct or not. 4.3. Then 1?
1 is 16.
16. Then 1.5?
1.5 is 30.37. 30.37.
30.37. And everybody check correct or not. 2? You can write the
2
equation
is
in the
40.
calculator, and programmable calculator can tell you the answer. What is that? 2 equal to?
It's 40, sir.
40. Oh, you did the calculation. And 2.5?
2.5 is 34.37.
34.37. And 3?
For 3, it's 0.
3, it's a 0. Good. Now everybody check if Muntasir is correct or not. And then you can go. And the lazy people, you just copy paste. And those who are having calculator can check and then tell them. Muntasir, did you do this calculation?
No, sir, I'm doing this.
Okay, a bit faster. Anybody got the answer?
Okay.
You can tell me also. I equal to what? And Q equal to what? Everybody check the answer is correct or not.
Sir,
Yes, sir.
sir, can I just divide it T by Q? without putting the value of t in I equation.
Yeah, you
Just
can.
divided.
And what is the answer you got?
Actually, I got for 1, 2, and 3. I do not this fraction part 0.5 or 1.2.
Okay, you got the value for
didn't see
I.
that.
Did you get the value for I?
Yes, sir.
What
But
is
not
that?
all the values, sir.
So find what is the
Sir,
value for I? Tell me first. T equal to 0 equal to what?
in 0 equal to 0.
0 equal to 0.
In
Good. Then
1
next,
second,
it is 1 second.
16. 1 second. Yes, sir. I didn't do the
No,
0.5
0.5
second.
you have to do. You have to do because we have to draw the graph. Main thing is graph because we need to, after that, we need to understand the interpretation of the graph. Bit faster. Anybody done it? Bit fast. You all don't need to
Sir, I can
type
say
it
it,
to
sir.
the calculator, the equation, and then programmable calculator can give you the answer one by one. Yeah, what is that?
Sir,
0.5.
8.6.
0.5 is what?
8.6.
That's good. That's the thing I want to know. 8.6. Then 1?
17.
17. Good. Then 1.5?
0.5, it's 17.
1.5
0.5 17, sir.
0.5 is 17.
Yes, sir.
Yes, sir.
That's the thing I was
sir.
talking about.
No. You don't need
If
to
I
talk now
use-
about it. Later on. First, we don't have enough time. Later on, we'll discuss about this. Alternative way, we'll discuss later. But this way is straightforward. You tell me the answer first. Okay, 17.
Yes, sir.
Okay, then 1 equal to what?
17,
28, sir.
28,
28. Later on, we can discuss about the calculation method.
27,
And 1.5?
27, sir.
27,
27. Good. Then next 2,
8,
8, sir.
8. Then 2.5?
minus 35,
Minus 35. Good. Then 3?
Minus
minus
108.
108.
Minus 108. Okay,
8.
so these are the values we get for Q and I, and now we are going to plot it. That is our next step, and everybody can do it, that how to get the plot, and we can see, you can do it on the same graph or you can do it in a separate graph. Now all of you plot it like this. If it's a separate graph, no problem. Like a small, like this and this, you have to draw. This also can be done. So you can draw here the Q, and this is I, you can draw. So take the point 0, 1, 2, 3, then this is 1.5, 1.5, 1.5, like that. And if you get the point, then you see that 1 and 2, and this is 3, right? So at time 2.12, you get the maximum. So you can find it here like that. So if you got the point here, 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 sort of points, and you get the point here, here, and here is 0. So the curve will be coming here like this, and this. You can check your graph after drawing the points. Are you getting? Yes, this is the maximum point you are getting here, which is 40.5. Right, and at 2, you get 2 is here, which is 40. You got 40 coulomb at 2, like sort of thing. So this is the maximum point, 2.14 you can have. So this is what the curve you got. The green curve is the Q versus, this is Q versus I, Q versus T. This is the curve you get, Q versus T. Is it okay?
Yes, sir.
yes, sir.
Good. So this is 0. And then you go for this curve. It is 0. And then go for it. 1, 2, 3. So 1 is here, 2 is here, and 3 is here. This is 0. So you can see now, this is your I versus T curve will be this one. But I'm just going to draw later about it. Now look at it. If you now put the point from first point is coming here at 0. First point is coming here as 0. And second point is going to be, okay, 0 point is coming here 0, 0. Then 1, 0.5, 0.2, 0.3. If you go like that, then you can see the points are coming in that way, here, 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 and here, like sort of things. Can go first up, and it is coming down the point here, and one point here, and the other point is here. So if you go the points, if you draw, then you can see the points are coming like this, and coming back to this point, which is minus. This is assume that's a minus. This is just assume like that. A little bit draw the point like that. Okay. Okay. So this is dot dot dot. This is the point. One point you got. This is another point you got. This is minus 108, and this point is minus 35 as you got the value. So this is the 2 points you can have. So if you draw the graph like that, okay, so the graph will be coming like this. This is your I versus T. I versus T. Q versus T and I versus T. These are the 2 graph you can have. This is your current curve, and this is your what is all this charge curve. So Q versus is it okay? Most of you are getting something like this.
Yes, sir.
Yes, sir.
Muntasir, what happened to you?
Yes, sir.
It is not the thing you got.
It's done, sir, and it's clear.
You made a mistake here in I, right? Now clear.
Yes, sir.
Can
Yes.
I
I appreciate you because you tried your best before the class. I hope that after the class, you will be much clear compared to any other students. I'm pretty sure. Okay, good. Now look at it. This is finished, fine, no problem. But I'm now going to give you the interpretation, physical interpretation of this thing. What is the physical interpretation? All of you try to understand. When you are giving the mobile battery for charging, or when you are going to charge the capacitor, whatever, when it is charging, then the capacitor, your mobile you given for charging, and it is charging, and it comes here, and a maximum charge occurred. It is the maximum charge happened. Now you look, when it is charging here, ting, 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 when it is charging here, charging, that time, what happened? The current is increasing or decreasing? When the current is flowing or not? When the battery is charging, then there will be current flow, right?
Yes, sir.
Otherwise, your mobile cannot charge, because the current is flowing through your mobile battery. That's why when it is charging, this is your charging. And what happened here in this phase? It is charging and fully charged. Charging and fully charged. After that, what happened here? It is going down. Means what? When you start calling from your mobile, then mobile is charging or discharging?
Discharge.
Yes, this is
Discharging,
your
sir.
discharging. Yes, this is your discharging period. Discharging here, and this is charging, this is discharging. So from here to here, it is charging, and when it comes to the maximum, no more charge. After that, you take it off and you start talking, then it is discharging. I'm just giving an example of the mobile is for easier understand. So when it is going, it is charging your battery and fully charged. After that, you're talking to your friends, then your mobile is discharging. Think like that. So this is the charging, and that is the discharging, and the maximum charging. When it goes to the maximum charging, at this point, what is the time at the time? Remember, maximum charging time at what time?
2.12.
Good.
2.12.
Good. 2.12 maximum charge. Now current, when it is fully charged, what will happen? Any current will flow through the mobile battery at the time?
No, sir.
No, sir. Good. Because at that time, the current flow will stop. And that is the thing. This is the current waveform. If you go to the current waveform, it is, what is this? This is 0. So this is what is the point of 2.12 second. So at 2.12 second, the current is going to be what? Hey, Doc.
0.
The zero.
Negative.
So negative.
sir.
Is it negative? Current?
Sir,
No,
Current is
sir.
what here?
Zero.
Zero. Who said negative? Okay, current.
sir, I
over
was
here. Yeah,
talking about that the current will go to negative direction from.
that is next question. I am asking you this question. You give me the answer here first. Try to get my point. Everybody should
Zero.
understand it. Yes, at 2.12 second, current is going to be zero. That means at 2.12 second, the battery is fully charged. As soon as the battery is fully charged, there will be no more current flow in through your mobile battery. That is the point. What is that point? That is point is 2.12. So I'm talking about, if you draw the curve, you can see the curve will go like this. The current curve, you can see current curve is like that, right? It's just together. Then this is going through this thing. I'm talking about that. So 2.12 second, the current of the battery is zero at that time. Yeah, now your friend who said negative current, yeah, you are right. Now you are going to discharge the battery. From after this, the discharge starts. The discharging the battery means current now negative. Why? Because at the time of charging your battery, current was flowing from your power supply to your mobile. You get into the battery. Mobile battery is going to the mobile battery, into the mobile battery. So battery was charging. But when you are discharging, take the connection out and start talking to your girlfriend. That time the battery is giving the current or receiving the current.
Sir,
Giving the
sir, we
Yeah, I'm
we cannot
sorry.
see the space.
Yeah, I'm sorry, just made.
Sir, but here I want to ask a question.
Go.
That we are not disconnecting it from the charger when.
Oh no, no, no.
this,
I'm
situation
telling
is
you.
happening.
Listen. This is an example I am telling you for your understanding. But if you have a, if you come to the real example, I'll tell you later. But for the time being, I'm just telling you. If you disconnect it here, then it is discharging, right?
Right.
Yes, sir.
Try to understand that way. This is the class for understanding the thing. I'll tell you later the real part. What is the real thing going on there? We'll discuss it later. But tell me the reality. If you do this, if you charge the battery up to this and battery is fully charged, and you take it out and start talking, then the battery will be discharged. It is true or not?
Yes, sir.
That is my ask. Don't
Yes, sir.
go
True,
for
sir,
reality.
true.
I'll come to that later. Don't divert the people to other direction. Try to understand my point. Later on, we discuss it reality. Please. Okay, now let's come back to the point. If the battery is discharging, the current is now flowing in opposite direction, because in that case, battery is delivering the current to the circuit. And during the charging time, battery is receiving the current, and that's why it is charging. And discharging time, that means when you are talking, that time battery is delivering the current to the circuit, giving this. That's why current is negative during the discharging time. And this is the current charging time, current nature, and this is discharging time, current nature, which is negative. Now the guy, you told me negative current because it is indicating the discharging current. That's why it is negative. And over here you can see throughout it is positive. So the current is positive because the battery is charging here. You understand? You can, I think everybody got the point why it is negative current. Because
Yes, sir.
discharging time, the battery current direction is opposite. That's why negative current is coming there. Okay, fine. And charging time is positive. You can ask me the question here only, that sir, how come it is a curvy thing here? That can be a good question. That if this is the question you ask, then you can see when the battery is charging slowly, initially the current is going to supply, going to the higher, and when the battery is up to the midpoint, when the battery is trying to fully charge, that time the current is slowly dying to zero. This is the reason why current is increasing at the time empty. When is an empty tank, that time the current is flowing more. At a certain time, slowly the current is decreasing. Why current is decreasing here slowly? Because the battery is slowly slowly charging in full. When the battery is fully charged, you cannot say straight or go and jump down here, not like that. Slowly the current will be dying to zero when it is fully charged. This is the pattern of the, but all the time you have to understand the current is positive, either here, everywhere current is positive. But after at the discharging time, all the time current is negative. But charging time, all the time current is positive. This is the actually interpretation of this thing. Now let's come back to your friend, the real circuit. Yes, the real circuit is something like this. If you can draw the circuit like this, up to that, we can have a circuit. I can show you here in a separate one, then you can understand better. Okay, the real circuit can be like this. It's a charging here, it's a discharging here. Again from here, another phase can go charging here, discharging here. Another, this can be developed by a circuit using RC. That's a capacitor device you are using. So using this capacitor, RC, and a 5-5 timer all together, you can develop a circuit which can go like this: charging, discharging, and again charging, again discharging. Charging is like this is giving you the like a things like square wave, like a twinkle. So it is giving you 1 0 1 0 1 0, like that sort of thing. The charging and discharging phase is coming like that, like that. So it can be used as a light, two light, one is on, another off. Again this is on, this is off, then again it is on, off, like a nitrate, a twink, what do you call that, blinking eye, like this eye, this light is on, this light is off, light on. So when this is charging, this light is on, when that is discharging, is like that sort of circuit. You can say charging discharging circuit. So you can do that way using the electric circuit, using RC, 5-5 timer, or op amp 741. You can see this sort of complex circuit in future, and that circuit can go on like this. So you can be asked to design a square wave generator. So a square wave generator should be like this, given that comes from this sort of charging discharging phase. So from this charging phase you're getting 1, discharging phase you get 0, again charging phase 1, again discharging phase you get 0. Like that you have to trigger the pulse and you can get the square wave. That sort of things in electronics you'll come to know in higher study when you go for level 2 or EEE 209 301. That time you can see. But that is the circuit which can give you instantly charging and discharging. That's the reality. That's the reality of this graph. It is not like the mobile. There's a mobile. I have just given an example. You understand the guy who asked me this question?
Yes, sir.
Good, excellent,
Yeah.
beautiful.
Thank you, sir.
Okay, now let's come back to the next point. We are jumping to the time. I think it's a I think we cannot finish this thing because this is another very important problem and we don't have enough time. I think next class, and very important, that's why I'm going to talk about it in details. This is the solar panel, you know, that PV photovoltaic panel related question. So this question is very much important. Nowadays people are moving towards this solar panel thing. So you need to understand about these things a little bit details. So next class at the beginning I'll talk about it, and then after that we'll jump to the next slide. I'll send you the slide for the next class and you go through the slide next class, and also you can go through this problem, I think, so that we can discuss this problem next class onward. Today I don't want to start, otherwise it takes time to explain the whole thing. I know Muntasir had solved the problem, which is very straightforward, but I need to explain the thing first so that everybody can understand about the PV panel characteristic. This is the PV panel characteristic curve. So the PV panel is a very important thing, how this curve and what is interpretation, and this, that is a little bit knowledge is required for you for your future. That's why I will talk about it next class at the beginning, and after that the slide I will start with the lecture slide. So I'll send you the lecture slide, or you can go through that before coming to the class. Lecture slide I will be uploading in the BUX. So email very much, I think you don't need to get any email from me, because you will get the information from the BUX online. So all of you can take your information from BUX. Is it okay with you all?
Yes,
Yes,
sir.
sir.
Good.
Yes, sir.
I think the class is over. I think you might have some other class. Those who are having, you can drop it, no problem. And those who are not having class, if you have any question, can ask me now. Within 15 minutes, we have to finish because I have another class after that. Any question overall? Any question or everything is fine with you?
Sir, I have a question.
Yeah, those who have question, you stay back. Rest of you can jump up. I think that should be fine. Thank you very much. Thank you for attending the class. Thank you. Yeah.